Hello everyone, welcome back to the Kemet Maasai Academy. What we're going to be doing today is looking at intersection and subsets. If you have not subscribed to the channel, I urge you to do so now. Just click that button, that subscribe button below, and tell your friends, tell everyone to come on over and listen to watch some of these videos. Because remember, we have mathematics videos from grade 4 all the way to grade 11 maths, as well as motivational videos. So let's go. We're going to be looking at the intersection of sets and subsets. So let's look at the definitions. The intersection of two sets contains the elements that both sets have in common. So we have videos that were done introducing the topic of sets, so you can always go back and watch that. But for the benefit of those who are just watching this video on sets for the first time, being introduced to the topic on this video, let me just explain to you that a set is a collection of items, things that have something in common, some property that they share, right? And we use a Venn diagram to represent sets. So the members of the set are called the elements of that set. So if we have two different sets, and there are elements in one set that are also in another set, we call that the intersection of the two sets. We say that those two sets have those elements in common, and this is how we would represent that on the Venn diagram. So you would see this is a universal set, so the rectangle represents the universal set, all of the elements that are being considered. And then we have the sets within the circles within the rectangle to represent the different sets. So where the sets share elements, you're going to see them overlapping. And this little section where they overlap is what we call the intersection of the sets. Now I've shaded that region here in the middle. So, excuse me, whatever is in set A and also in set B would go in this little space here, in the intersection. What is in set A alone, says whatever is in set A but not in set B would go here. And what is in set B but not in set A would go here. Okay, so this is A only, B only, and this is where A intersects B. So this is the symbol that we use for intersection. Some people call it an upside down U. And this is the word intersection. So the intersection of sets. Now, if two sets do not intersect, because they don't have to intersect, they can be a part of the universal set. So they can be a part of the big group, but they themselves do not share anything in common other than being a part of that big group. So if two sets do not intersect, we say that they are disjoint, right? And here we have the diagram representing disjoint sets. So they are still members of the universal set. However, they do not intersect. They don't intersect each other. They are disjoint. And if we're asked to list the elements of the intersection of two sets that are disjoint, all we need to say is, if set A intersects set B and they are disjoint, their intersection is the empty set or the null set. That means there are no elements in their intersection. So these are the symbols. Both these symbols are used to represent the empty set. The null set contains no members. Disjoint sets have an intersection that is empty, null. A subset is a special intersection where all the elements of one set are contained within the other set. So a subset is a special kind of intersection of sets. If one set has elements that all of those elements are contained within another set, we say that the smaller set is a subset of the larger one. It could even be that all the elements in one set are exactly the same elements in another set. That is also a subset. I'll explain to you the two types of subsets that we have. But here is the diagram representing. Still have our universal set. So these two sets are part of the universal set, the bigger group that is being considered. But if you notice, there's a special way that we draw the intersection that shows subsets. See? Everything in A is also in B. So we don't draw their intersection like this. We draw their intersection where we have concentric circles, a smaller circle A within a bigger circle B, or whatever the letter that is being used to represent the set. It doesn't have to be A or B. It could be any letter or symbol used. So we say A is a subset of B because all the elements of A are also in B. Now, sorry, this is the symbol that's used for subsets, right? Now, if the subset is equal to the other set, so in other words, if all the members of one set are exactly the same members of the other set, then this is the symbol that we use, right? If it is a proper subset, this is the symbol we use, and the proper subset just has some elements that are members of the other sets, right? So you will see these two symbols being used for subsets. Alright, now what we're going to do in our activity here, we're going to list the intersection of the sets. So set B has elements 3, 5, 7, 9. Set D has elements 5, 6, 7, 8, 9. And set F has elements 1, 3, 5, 9, 11. So remember, their intersection is what's common to both, which elements are in both of them. So what would be the intersection of B and D? What is B intersect D? So let's see, what's common to B and D? So we have a 5 in B and a 5 in D, so 5 is common. We also have a 7 in B and a 7 in D. We have a 9 in B and a 9 in D. So there are 3 elements, the 5, the 7, and the 9 that are in the intersection of B and D. Alright, how about D intersect F? What is common to D and F? So in D we have a 5, we have a 5 in F, we have a 9 in D and also a 9 in F. So the intersection of D and F, the elements in that intersection would be 5 and 9. How about B intersect D intersect F? B intersect D intersect F. So that means what is common to all three? What is common to all three sets? Is there anything that all of the sets have? Alright, just looking, I'm seeing that all the sets have a 5. These two have a 3, but this one doesn't, so the 3 is not common to all of the 3 sets. The 5 is common to all 3, and the 9 is common to all 3. So the intersection of all 3 of those sets would be 5 and 9, and we put them in curly brackets, separated by commas. So when we're listing the elements of sets, we use the curly brackets and we separate them with commas. So let's look now at these sets. We have set P that has a circle, a triangle, and a square. We have set Q that has a circle and an asterisk. And we have set R that has a rectangle, a triangle, and a shape looking like the letter S. What is P intersect Q? What is common to P and Q? The circle is in P, the circle is in Q. So that is their intersection. Just the circle, nothing else is common to both sets. What is Q intersect R? What is common to Q and R? Is there any element that is in Q that's also in R? Actually, there isn't. So remember, if two sets have nothing in common, they are disjoint, and their intersection is the empty set or the null set. So we're going to put the empty set, empty curly brackets, or we can put a circle with a line drawn through it to indicate also the null set. Set G has elements Monday, Tuesday, Thursday. And set H has elements Monday and Tuesday. What is G intersect H? What is common to both G and H? Both of them have Monday, both of them have Tuesday. So their intersection has two elements. Put our curly brackets and we're going to put Monday and Tuesday. Monday and Tuesday are common to both sets. We could also say, since everything in H is contained within G, G has an extra element that H doesn't have, right? So they are not equal subsets, they are proper subsets. Some elements, the elements in H, are contained within G. So we could say H is a proper subset of G. They are not equal subsets, right? They don't have the exact same elements. But H is a proper, this one, not the one with the line under, proper subset of G. So what we're going to do now, just a little activity. we have a Venn diagram and we have some sets. Some are overlapping, so there is some intersection, and some are disjoint to each other but still having intersections with other sets. So we're simply just going to list the elements in the intersection. Just a quick little activity. So based on the Venn diagram and looking at the different sets, what would be A intersect B? What is common to A and B? There are actually two elements that are common to A. If you look where set A, this is set A, where it overlaps set B, we see that the 1 and the 4 are common to both sets. A intersects C, where set A overlaps with set C, we see that the 1 and the 3 are common. B intersects C. So this is set B, and this is where it crosses set C. So the 1 and the 2 are common to B and C. How about A intersect D? A does not touch D at all. They do not overlap. So remember what we say we do when two sets are disjoint. When they don't overlap and we are asked to list their intersection, we say that their intersection is the empty sets, which any one of these symbols can be used to represent the empty set or the null set. How about E intersect D? Everything in E is contained within D, so E is a subset of D. We can write that E is a proper subset of D. So let's list out there. If one set is a proper subset of another, their intersection is automatically the smaller set. So remember, it's automatically, this is their intersection. One set is contained within another set. Their intersection is a smaller set. So the intersection of E and D then would be E, which contains 9 and 15. B intersect E. Again, B and E do not cross each other. They do not intersect. So their intersection is the empty sets. How about A intersect B intersect C, where the three sets cross each other? Can you identify where the three sets overlap each other? So we have set A, set B, and set C, where they all overlap right in the middle here. Okay, so where three sets overlap right in the middle, so that is the element there is 1. Okay, all right, so that's it for intersection. Remember, an intersection of sets are the elements that are common to the sets being considered, whether it's one set, two sets, three sets. The elements, well, you can't have one set intersecting, but whether it's 2 sets, 3 sets, 4 sets, no matter how many sets crossing each other, the intersection is the overlap. And remember, if sets are disjoint, it means that they don't intersect, and their intersection is the empty set or the null set. Subsets are a special example of intersection where the elements of one set are contained within a bigger set. And you can have subsets where the sets are equal, they're identical, the elements are identical, or we can have proper subsets where one set contains elements that are in a bigger set and the bigger set will have extra elements in it. So that would be a proper subset. If you have benefited from this video, I would love for you to share the video so others may benefit as well. And if you have not yet subscribed, now would be the time to do so. Tell your friends, your neighbors, your classmates so they can subscribe and take advantage of the videos. And I will see you in the next